Hey guys, I'm back with another coding interview practice video. This week's question was requested by a viewer, Angela. Given a collection of distinct numbers, return all possible permutations. In this case, a permutation is a variation in which a group of numbers can be ordered. For example, 1, 2, and 3 have the following permutations: 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, and 3, 2, 1. If you look online, there's a whole bunch of ways to approach this problem, but I'm going to go with the way that made the most sense to me. When I see problems like these that can be broken down into smaller problems, I like to use recursion. That way, instead of solving some huge monstrous problem, I can solve the small, easy version of that problem, called the base case, and figure out how a bigger problem can be broken down into a smaller problem, which is called the recursive case. Solving the base case tends to be pretty easy. In this case, the smallest version of the permutations problem is the case where no numbers are given. In that case, the only permutation is the empty list. So we return a list of the empty list. The hard part about recursion is figuring out the recursive case. In my opinion, the best way to do this is to write out some of the smaller solutions and figure out how they relate. Here I have the solutions for the case of no numbers: 1, 1, 2, 1, 2, 3, and 1, 2, 3, 4. The pattern is a bit hard to see at first, but it becomes more and more clear as we get to the larger problems. Let's take a closer look at 1, 2, 3. We know the permutations of 1, 2 are 1, 2, and 2, 1. On the last line here, we see that we just add 3 to the beginning of the permutations for 1, 2. We repeat these for the other numbers, adding 1 to the beginning of the permutations for 2, 3, and adding 2 to the beginning of the permutations for 1, 3. Combining all of these, we get the permutations for 1, 2, 3. We can see the same pattern for 1, 2, 3, 4. We add 1 to the beginning of the permutations of 2, 3, 4. We add 2 to the beginning of the permutations of 1, 3, 4, and so on for 3 and 4. So the recursive case boils down to, for each number in the collection, add that number to the beginning of all permutations of the remaining numbers, and concatenate all these results. Let's code this. We'll start off with the base case. If nums is empty, we return a list containing just the empty list. Now for the recursive case. We'll initialize an empty list, permutations, that we'll use to contain all the possible permutations. Let's create a for loop to go through each number in nums. We'll use this Python function called enumerate, which allows us to access both the index and the value as we loop. Now we want to add the current number to the beginning of the permutations of the other numbers. To get the permutations of the other numbers, we simply call permute with the other numbers. We can get the other numbers using list slicing. We take the list from the beginning up to but not including the current index, and then we take the list from the current index plus 1 to the end. Let's place these permutations of all the other numbers in a variable, other permutations. In order to add the current number to the beginning of all these permutations, we'll use a function called map. Map takes a function and a list as arguments. It applies the function to each element in the list and returns the resulting list. In our case, the function we want to apply will add the current number to the beginning of each permutation in the other permutations list. We'll create a lambda function that takes one argument. We'll label it permutation, and it'll return that permutation with the current number added to the beginning. We'll map this lambda function onto the other permutations list. And then we'll concatenate these updated permutations to our permutations list. When we're done with these loops, we can return permutations. Let's test our permute function with the numbers 1, 2, 3. And it matches what we expect. Mapping in lambda functions can be a bit tricky to understand if you haven't seen them before. If you guys want a video covering them in depth, let me know in the comments. Thanks Angela for requesting the question. If you have any problems you want me to cover, leave them in the comments below and I'll try my best to answer them in my next videos. If you enjoyed the video, drop a like. If you want to see more, subscribe to my channel, and I'll see you all in the next video.